Hello, students. At this point, we've seen a variety of different ellipses, and we know that some of them are more elongated and some of them are more round and kind of closer to a circle. And there's actually a measurement of how elongated an ellipse is, and we call this the eccentricity, which we represent with the letter E. Now, this letter E is not to be confused with the irrational number that we represent with the letter E as well, 2.71828, etc. This is something that we use only with ellipses, and so we should recognize that if we see the letter E when we're dealing with an ellipse, it probably refers to the eccentricity and not the number E, 2.71828, etc. And so the eccentricity can be measured by taking the ratio of C over A, where we remember that C is the square root of A squared minus B squared. This is one way to write the relationship. I think earlier we saw C squared equals A squared minus B squared. I've just taken the square root of both sides to get C on its own. And so this is a way that we can measure how elongated or how round an ellipse is, and always E is going to be a number between 0 and 1. And so if E were 0, it's not actually allowed to be 0, it has to be greater than 0. But if E was equal to 0, that would mean that C was equal to 0. And remember that C is the distance between the center of the ellipse and the foci. And so if that was the case, both of the foci would be at the very center, and we would actually have a circle. So if E was equal to 0, this would actually be a circle. So the closer E is to 0, the more circle-like our ellipse will be, and the closer it is to 1, the more elongated it would be, right? This is definitely not going to be a perfect drawing of an ellipse. I just did it by hand. But we'll get something that's more elongated as the eccentricity gets closer to 1. So let's actually take a look at an example. Find the equation of an ellipse with foci at 0, plus or minus 6, and eccentricity, E equals 3/5, and then sketch the graph. So because the foci are located at 0, plus or minus 6, this tells us that the value of C is equal to 6, because each focus is 6 units away from the center of the ellipse, which is at the origin. Now, we know that E is equal to 3/5. We have E is equal to 3/5. But remember that E is equal to the ratio of C over A. So in this case, we know 3/5 is equal to 6 over A, because we know that the value of C is 6. And then this can be solved by cross-multiplying. We get 3 times A equals 5 times 6, which is 30. And if we divide by 3, we get A equals 10. Now, because the foci are located at 0, plus or minus 6, these are on the y-axis, up 6 units and down 6 units. In fact, we can plot these on the xy plane. So they're at plus or minus 6. Because the foci are located vertically, we know that we're going to have an ellipse that's taller instead of one that's wider. And so the major axis is going to be vertical. And because A is 10, we know that the vertices are going to be at plus and minus 10. So we know how high up and down our vertices are. Next, we need to figure out what's going on along our minor axis. And remember, to do that, we need to find B. And we know that C squared is equal to A squared minus B squared. And we know the values of A and C, so we can use those to figure out the value of B. C is 6, and A is 10. So we've got 6 squared equals 10 squared minus B squared, which gives us 36 equals 100 minus B squared. If we subtract 100 from both sides, that gives us negative 64 equals the opposite of B squared. If we divide by negative 1, that gives us 64 equals B squared, and taking the square root, we get B equals 8. So that tells us that along the minor axis, our intercepts are going to be 8 units to the right and to the left. And so now that we know the values of A and B, we can use those to sketch a graph of our ellipse, which is going to be taller than it is wide, which we can see once we graph this. And then we can write out the equation x squared over 8 squared is 64, plus y squared over 10 squared is 100, gives us 1. So this is the equation of that ellipse. We also have the graph of the ellipse. We know the foci, etc. We've got everything we need to deal with this ellipse. In the next video, we're going to look at some interesting physical properties of ellipses.